Hi everyone. Hi Lorenzo.
Hello.
So today we have Lorenzo here, and I've got several questions about Exosim 2, which I hope you can answer
Sure.
for me.
Let's try.
So what is Exosim 2 then?
So Exosim 2 is an observation simulator. Basically, it produces mock images of your telescope while it's pointing at the target.
Sounds good. I've got my next question here. Why is this so important for Ariel?
Well, Exosim 2 as an observation simulator is not important just for Ariel. Every telescope or observational facilities has something similar or an adaptation of Exosim 2 because every telescope needs to know what kind of image to expect out of an observation. In the case of Ariel, we are using this to assess what are the astronomical or instrumental effects that are affecting your observation, and therefore developing the trending techniques to remove all the systematics and the noise and actually get the real flux from the sky.
I see. You've told about sort of an overview of Exosim 2, but tell me, how does it work?
Well, Exosim 2 is a complicated framework that inputs physical models defined by the user. In general, what it does is start by simulating the astronomical scene. So you have a star, which can be static or time evolving star. Then you have the starlight going through your telescope and going through every single optical element up to the focal plane. When you reach the focal plane, this information is convolved with the PSF. The PSF, or point spread function, is the image of the star, or a single star in the sky, down to the focal plane, so to the detector. If you are talking about a photometer, then this is just a blob, or if you are in a perfect situation, is a circle. But if you are talking about a spectrometer, then you have a different PSF for every wavelength, and the combination of those produce that line of light image that you have seen. On top of that, you need to take care of informations like the fact that every pixel responds to light differently in the center than on the edge, and therefore there is a convolution between the shape of the PSF and the actual shape of the pixel. And then, because your detector is real and not ideal, every pixel also responds different to light. Do you have dark current? You have different amplifiers that read out your pixel, and all these information are combined all together into Exosim 2.
And I'm assuming that because we're talking about in the context of the Ariel Data Challenge 2025, are all of these processes that you just described inside ADC 2025?
Yes, these processes and more. Into the Data Challenge 2025, we are put all this information like the pixel shape, the PSF, the optical chain of Ariel, but we also started introducing some astronomical effect like the dim darkening coefficients that affect the shape of the transit light curve. Then we have gain drift, we have the jitter noise, which is an effect that combines the vibration of the telescope and the shape of the edge of your pixel, and all of these are in the challenge to make the challenge as realistic as possible.
That sounds good. Have you got any final thoughts on the data challenge?
Well, I think the participants have all the information they need to tackle this challenge. I will say keep posting your question on Kaggle, on the discussion section, and we will keep watching that.
Yeah, we'll be keep watching that. Well, Lorenzo, thank you very much for answering all these questions. I'll be walking away now, but thank you very much for your time.
Thank you.
Yeah, I've got one. Well, actually, I've got one thing that I think might be quite.